Hi there and welcome back to Triplicate, and yes, it is time to have another go at the Heresy Radical Synthesizer. I bet you were all wondering what had happened to it. Well, it's back again, and I did look it up. The last video was in February and it's now just turned October, so 7 months to go. Yep. So I thought at this point we'd do a quick recap. Now, I'd completely forgotten where we are with it. Well, not completely, but mostly forgotten where we are with it. So I've been working my way through the old videos, which is the first time actually I've seriously sat down and watched any of my old videos. And yeah, most of them seem alright. So we will start our recap by reminding ourselves of our I suppose design goals. We wanted to make a synthesizer without a black and white piano style keyboard, and we wanted to make a synthesizer with no MIDI, how the dinosaurs communicated with each other. We didn't want a conventional sound architecture of oscillators, filters, envelopes, LFOs, etc. And we wanted to design in, if we could, a little bit of attitude. So in this video we're going to pick up the sound generation system, and in the next video, which hopefully won't be another 7 months, we'll come back and revisit the player interface. Now, the sound generation system, we wanted something that actually oscillated and the player's input somehow drove the oscillation, rather than just what is conventionally called an oscillator, but is actually just a waveform generator. In fact, in a digital synthesizer, it just copies waveform tables out. I know, see them in green videos. So we started with, for a bit of fun, we made this little guy. Okay, so this is the business end. So this is a neon. It works by sending a current through a plasma and thus emitting light. This is just a DC voltage, about 120 volts. And this resistor and this capacitor charge up until this point gets to 90 volts. I mean to say with the neon off, so not conducting, and when it gets there the neon strikes and becomes very low impedance through the plasma. So then the capacitor then discharges quickly through the neon and blinks the neon until it gets down to a few volts where it can no longer sustain enough current to keep the plasma going, and the neon turns off and the capacitor starts charging up again. And we played with that for a while and ended up trying to mimic that turn on, turn off behaviour in such a way that we wouldn't get loads of horrible digital noise. And we ended up with carts going up and down hills and all sorts of things, and the end result is not a very good musical oscillator. I mean, this is how any RC oscillator would work, and a 555 IC and a bistable logic thing. They're all pretty much working on this principle. And while they produce nice, if you just want an oscillation for a basic timer or something, that's fine. For music, nah. So we abandoned that, not after quite a few videos. And we went to looking at trying to model that behaviour, blowing across the top of the bottle, and there we go, blowing into a wind instrument like this, or a recorder. And we also looked at bows on strings in a violin, and I haven't got a violin to demo, and we kind of got that working, a bow working with just a single oscillator, you know, like a mass on a spring bouncing up and down, driven by a bow, and that worked okay. But then we tried to make that only makes pretty much a modified sine wave, so we went over to trying to make to have lots of coupled oscillators, and got, I guess, sidetracked into playing with coupled oscillators. That was interesting, and we'll come back to it, but yeah, kind of lost track where we were going with it. So that's the advantage of having had some time off and reviewing what we've been doing, is that I've now re-looked at it, and I think I have a clearer idea of where we're going and what we should be doing. So let us take our pen and piece of paper and have a look at where we're going and what we're doing. Okay, so what we got working was pretty much modelling this system. We have a spring. Does that look like a spring? Nope. Well, a mass on the end, which will bounce up and down, and that is being driven by super drawing as ever, a bow, like a violin bow, which moves in either direction, one direction, whatever. And what happens is it uses the property of friction and stiction. That is, if I will show you with my pen, because of various things to do with the way physics and materials work, it takes more effort to push that, to get it moving, than it does when it's moving. And this is waxed horsehair, and it's carefully developed to work this way, that the stiction force and the friction force are quite different. So the bow moves up and pulls the mass when the mass is going the same speed as the bow, until the force pushing the mass back towards the centre, which it always doesn't, is greater than the stiction. Then the mass will swing pretty freely, while the mass and the bow are going different speeds, and come around and come back up again and catch the bow again and get another little pull. So the mass is actually getting a little pull every time it comes round from the string, and that's how it stays running. And there's always some damping in a system like this, which I haven't drawn here. So we were trying to model that, and I suppose we did, but you only get a sine wave, or a very close to sine wave, out of that. So then we were trying to look at sorry, ignore that horizontal line, it's a mistake. Coupled oscillators, multiple masses on springs, and use that to make a system that will produce more harmonics of some bass frequency. And we spent ages trying to work out mass values of these masses to do that, and we had some good fun, and we will probably revisit that at some point. But then we got to the point, well, we've got Our bow, where do we drive that? Here, there, the combination? Don't know. Did have some sort of a play about with it and could not get it to work as I wanted, and I think I just got fed up with the whole thing then, and that's why there's been no video for 6 months and some on this. So coming back to it again, I think I now realise that I was actually, despite saying every video just about that we are not trying to model a existing instrument, we are just going to trying to make a synthesizer using the principles of how actual instruments work rather than engineering blocks wired together. But I think I fell into that trap of trying to model masses and on springs and bows and what have you. So I've gone back and I said, well, what do we want the thing to actually do as a system, as a sound generator? Well, we want it to resonate. We looked at the what they're called relaxation oscillators, like our neon, and they're just not very stable and very good for producing a musical note. So we want something that resonates like our mass on a spring. And that's not the only one we can use, and we'll get to that. So we want a Resonator. Sorry if I've spelled that wrong. Spelling things wrong is something I do. And we want to drive that with the bow, with air blown over the edge, over a sharp edge, which is how they work. Don't know. We're not trying to model a system, so we're not saying. We don't need to say. So we want something to drive our resonator, and we want to drive from a constant control value, like the pressure of the breath or the speed of the bow. But again, it's just going to be a control value. We're not saying it is anything. So that's what it is. It's just a thing. And I thought about it and thought about it and thought about it, and this is something that doesn't actually exist. So I thought I'd made up a name, and the name I came up with is Encycler. So we have an Encycler. Might not be the best of name, but I'm not good at thinking of names. Which outputs some sort of a drive to our resonator to keep it resonating. And our resonator needs to send an input back to our Encycler. For instance, in the case of a bow, how fast something in the resonator is moving, so the bow so the bow knows when to catch it and push it. And the Encycler also needs control. And I've drawn it too near the edge of the paper. There you go. Which is, again, if we were thinking in terms of bows, it would be the speed of our bow, but to us it's just a control signal, probably the speed of our turntable. Who knows? And it might have more than one control. Indeed, the resonator might and probably would have more than one signal to tell the Encycler what to do. And after the resonator we have might think of a better name for now. It's the sounder. Sounder, Mr. U out. And out of that comes the output. and the sounder modifies the sound somehow passively. Maybe like the body of a violin, or it may be fuzz like the amplifier of a guitar. So that can be anything or nothing, and that is the architecture of the Heresy, of our synthesizer, and no reference to any physical instrument or system is required for that. So I am happy that that is a good starting point. Okay, so as I say, we're taking a fresh look here. So the first thing we're going to take a fresh look at is the resonator. Now, up to now we used a mass on a spring as our resonator, which is fine, we actually got it working, but you only get one frequency out of it, and most instruments have some harmonic, more complex harmonic content. Pure sine waves aren't very interesting to listen to. So then we looked at coupled masses like this, coupled mass on springs, and we spent quite a lot of time on them and didn't really get to where we wanted to go. So I have decided at this point, we'll come back to this, but at this point we are going to change tack. And why? Well, let's consider, whoops, oh dear, the string, a stretched string, a violin string, any sort of string. And the same argument goes for a column of air in a tube. That guy. Now, not going to get into this, but you can model this, and the way you do that is you assume your string consists of lots of strings and little masses on them. So every bit of string has a weight, and it's under tension, it stretches, so it has some spring. And oh looky here, that's just coupled masses, but to get a string you have to essentially make these masses very small and very close together, and do some calculus, and I might do a video on it sometime if anybody's interested in the maths of it. But we are going to bypass that, and we are going to say, if you have a string, I don't know, you've done it with a long skipping rope or a long rope, and you flick the rope and the little pulse travels along, it reflects off the end, either forwards or inverted depending on the system, and comes back again. So what's happening here? We're getting our pulse, it's going along here, and back here. So that is a delay line, which is very easy to implement digitally. And in fact, if you have had a play with the pulse saw, and please do if you haven't yet, link in the description where to find it. The phasor in that is simply a delay line, and these reflections and it coming back round, that's the output. We have a feedback amount which is at less than 1 or it'll run away, and we have a plus here, and we have our drive here, and our drive will be our encycler. So that is a lot easier to deal with. So let's set that up. I'm just going to set some test code up, and we're going to have a look at implementing a very simple delay line. And of course the with a string there are certain frequencies which will resonate, the ones that fit in the string. So that one, I'm just putting these marks so I can, that one, oh, that one, etc. So we can get a spectrum out of our delay line. So let's see what we can do by way of implementing a delay line. Yeah, well actually I think I'm going to end it there. And it's been a bit of a chalk and talk, as it were, video, but I think we really needed to do that reassessment and refocus of where the whole thing's going. And I think that's been a little sort of episode in itself, so I am going to finish this video here, put it out and move straight on with actually creating a delay line and seeing what we can make it do. So hopefully the next one will be out soon, but for now it's goodbye from Triplicate. Goodbye.